Greetings programs, Atari here, you there, and welcome to another in our series on Arduino Basics. Now in our last lesson, we learned how to take button presses that correlate with various levels of resistance and turn that into a sonic output. But enough with the buttons! We're going to do this with sensors! Now as we saw in the last video, we can take a circuit and vary its resistance by pushing different buttons and create different analog inputs for a specific digital output. In this project, we're going to take this sensor to give us various resistances to our voltage to do more or less the same thing. Now this is a photoresistor, and it takes light and converts the light into various levels of resistance to the voltage in this circuit. So with less light, there will be more resistance, and with more light, there is less resistance. And we're going to use this to create a sort of rudimentary theremin. Now, fun fact, the theremin was invented by this guy named Leon Theremin, who actually invented the concept that would later become RFID, and was responsible for planting one of the most infamous listening devices in the US Embassy in Moscow during the Cold War. We are definitely going to be talking more about that in a later video, so be sure to subscribe and don't miss that one. Now let's wire the circuit. A photoresistor is a component that varies electrical resistance based on the amount of light hitting it. It's done through the photoelectric effect, which is the same effect that makes solar panels work, and we'll talk about that in another video. We run a jumper from the 5-volt pin onto our breadboard and into one side of the photoresistor. The other side of the photoresistor then connects to the A0 pin on the Uno. It also runs through a 10 kilo ohm resistor over to ground. At the same time, we have pin 8 connected by a jumper to the positive side of our piezo buzzer, and then back over to ground. Now let's take a look at the code. This is the calibration routine. It's going to run for the first 5 seconds after the Arduino powers up. Then it's going to read and save the maximum and minimum values of the sensor. The map function remaps a number from one range to another. That is, a value of from low would get mapped to low, and a value of from high to high. The values in between to the values in between, etc. It adjusts the scale, essentially. In this example, we're matching the value of the pitch variable to a value from 50 to 4000 based on the values of the sensor during calibration. Now let's upload the sketch and see it in action. Now, what other sorts of sensors could be used to create analog values that we could convert into sound? Let me know down in the doobly-doo. And your homework is to build such a device. And that will conclude today's Arduino how-to lesson. To learn more about using the Arduino, click the playlist here and watch the entire series. And to get the complete show notes for this episode, including the sketches that are used, click the link right here. If you're interested in goofy electronics projects or learning more about various electronics platforms, click the subscribe button, and don't forget to click the bell notification icon so you don't miss anything. My name is Atari, and until next time, tally ho, y'all.